Complex fractions and unit rates. What is a complex fraction and where would you see one? All right, well, we're going to explore that question in just a second. Here we have an example. We have Evan is helping his mom garden. He's asked to plant seeds. Evan plants seed in 4 2/3 square yards in 2 hours. So the square yardage of this area is 4 2/3 yard, and it takes him 2 hours to do that. Who knew seeding would take so long? So how many square yards can Evan seed in 1 hour? That's what I want to know. How can you do that in 1 hour? So take a look at my example here. I know that the square yardage per hour divided by hours gives me my unit rate. So here's my problem. Here is a complex fraction. Why is it complex? Because I have a fraction within a fraction. Right. So I've got 4 2/3 divided by 2 hours. So I have to write it out horizontally. And then I think to myself, well, we can only divide fractions if they're both fractions. So I do that here. Change that to 2/1. Write down my steps here. So I write 2 as 2/1 to make it a fraction. My next thing that I've done is I change my mixed numbers of 4 2/3 into an improper fraction, 14/3. It's going to help me out a little bit easier. Then I remember that dividing fractions is easy as pie. I flip the second and multiply. And that's how we divide fractions. Remember, that's from our little song that we sang. Now I'm going to do some cross-canceling to simplify. And then I get my answer, which is 2 1/3. You can see 2 1/3 square yards, I should say square yardage, in an hour. So Evan can do that in 1 hour. So there's your first example. Now that you've seen an example, let's talk about what complex fractions are. So a fraction with a numerator, or denominator, or both that are also fractions. Say what? Basically, it's telling you that, look, within your fraction, there's going to be another fraction. So within the fraction, there's another fraction. Within the fraction, there's another fraction. Or maybe they're both fractions, numerator and denominator. So all these are examples of complex fractions. So let's go ahead and work this out. Let's simplify. 1/4 divided by 2, 1/2 of 1/4. So some of you might know the answer right off the bat, but others of you maybe not. It's fine. We're going to write it horizontally. I then change 2 into 2/1. I then divide fractions easy as pie. Remember this little song, flip the second and multiply. So I do that. Flip the 2/1 to 1/2, multiply straight across, and I get 1/8 as my answer. And that makes sense. 1/2 of 1/4, well, 1/2 of 4 is 2, so 1/8 would be 1/2 of 1/4. All right, let's take a look at the next one. 1 divided by 1/2. How many halves can you get out of 1? Some of you might already know the answer, which is fine. I start off with easy ones. I'm going to rewrite this horizontally. I'm going to change 1 to 1/1. And then I can flip the second and multiply. It's part of our little song for dividing fractions. Oops. Flip the second to 2/1 and multiply. Sure enough, it's 2. That makes sense. Look, if I had $1, write it over here. If I have $1, I want to know how many 50 cents can I pull out of that dollar. Well, you can take 2 of those. And that's really what this is saying here. All right, let's go to the next one. So Gio can jog 1 1/3 miles in a quarter of an hour. What is the average speed per hour? Well, what if he ran that same speed but it goes for a full hour? How far would he be able to run? Well, here we go. This is really asking me for 1 1/3 miles divided by a quarter of an hour. So I'll divide. Well, I start off with writing them horizontally. I then change 1 1/3 to 4/3, okay, to make it an improper fraction. Then I remember the song, flip the second and multiply, right? Dividing fractions, that's easy as pie. Flip the second and multiply. Just multiplying by the reciprocal. All right, so I've got that part down. Next, I'm going to go ahead and just multiply straight across. That's 16/3, which as a mixed number is 5 1/3. What the heck does that mean? That means Gio, if he ran at that rate, he could jog 5 1/3 miles in the full hour. Way to go, Gio. What a athlete and scholar. Whoops, that's not me. Over here. So some of you might have gotten this game already. I know I won't be getting it for a while, but hey, some of you are actually playing this game instead of actually doing math. So why don't we incorporate the both? So Nicholas, he's playing a new video game. He destroys 240 zombies in 2.5 hours. Plays for 2.5 hours. Mom or dad says, hey, no more. Gotta do your homework. Says, okay, I'm going to look at my score. 240 zombies in 2.5 hours. All right. I want to know how many zombies does he destroy per hour? All right, so here we go. Here's my complex fraction. 240 divided by 2.5 hours. I rewrite it horizontally. I change 2.5 to 5 halves as an improper fraction. I then also change 240 to 240 over 1 to make it a fraction. That would be helpful. Then I can remember that dividing fractions is easy as pie. I flip the second and I multiply. I can do some cross-canceling here, which I've done here. The 5 and the 240 turn into 1 and 48. And then I can multiply, find out 96. Hey, therefore Nicholas destroys 96 zombies per hour. Don't worry, he's a newbie, so he's getting better each time. Just kidding, I haven't even played the game, so who knows. Anyway, those are some examples of complex fractions and how to find unit rates with that. Make sure you have your questions ready for tomorrow, and we'll explore this some more.